Okay, welcome back. This is our fifth lesson on radical expressions, and in this lesson we are going to finish the topic of how to rationalize denominators. Now remember that the word simplify has hidden rules within it, and one of the hidden rules is that we cannot have fractional exponents in the denominator. We think of this as AKA no square roots or no cube roots or any roots in the denominator. So we have to get rid of roots that appear in the denominator or get rid of radicals in the denominator. Now we've been looking at this in terms of radical 3 in the denominator, but we're going to look at this in the next lesson as 5 over 3 to the 1/2, where we actually look at a fractional exponent. These mean exactly the same thing, and if you've watched the snow day videos you already know this. But right now we're just looking at everything in radical form. So we have to get the roots out of the denominator. So reminding you, to rationalize the denominator means to what? Get rid of the roots. So we're getting rid, so I guess the directions are to get rid of the roots in the denominator. Now, this is to be very specific. Get rid of the roots in the denominator. Now, we look at this example. We're going to change up today a little bit. This is 5 over root 3, and just a quick review of yesterday, we have 1, 3, and remember that our index is 2. And in order to take, or to get rid of the root 3, we have to create a group of 2 or a pair of 3s. Since we have 1, 3, we only need one more. So we're going to multiply by one more root 3, or I should say we're going to multiply by the square root of one more 3. Now, 3 times a 3 and a 3 make a total of root of 3 squared. So now we have 2 3's in the denominator. Remember, we can multiply the 3's together. And on top, we have 5 root 3. We can take out a pair of 3's, which leaves us with just a 3 in the denominator and 5 root 3 on top. So you can watch the last video to see how this process works. Now, the question today is, what happens, notice, on this problem, 5 over root 3, we just see a single radical in the denominator. But today we're going to look at what happens when we have addition in the denominator. So in this case, 5 over 2 plus the square root of 3. How do we get rid of a radical in the denominator when there is addition? Okay, so in this case, now we have addition separating two products, or we call this a binomial. Remember, addition splits things apart. So we have a binomial in the denominator, and it is split apart. We have two monomials split by addition. How do we get rid of the root when there is addition? Well, let's try the process we just used. If we try to multiply by root 3 and root 3 to create another 3, watch what happens. We end up on top with 5 root 3, but what happens when multiplication meets addition? Remember that distributive property applies. So we end up on the bottom with 2 root 3 plus root 3 times root 3 is just 3. So we get rid of the root here, but what happens? We create another root on the other side of the addition. So this process does not work. We got rid of one root, but in doing so, we created another root on the other side of the addition. So this process of multiplying by root 3 is not going to work. So we have to figure out something else. We don't multiply by root 3 over root 3. We have to figure something else out. And this is where we introduce one of the most important terms in this class, the word conjugate. So I want you guys to write the word conjugate down. And I want you to write conjugate means change the middle sign. And this is all over your SOL. So change the middle sign. So I'm going to ask, what is the conjugate? I'm going to give you examples. So conjugate literally means change the middle sign, or you can think of this as opposite middle sign. So if I write x plus 5, and I ask you, what is the conjugate? We change what? We change the middle sign. So the conjugate of x plus 5 is x minus 5. Notice, did we change the front sign? No, we just changed the middle sign. So positive changed to negative. Notice up front, the positive x stayed positive x. If I give you negative 3 plus the square root of 2, what is the conjugate? Remember, conjugate means change just middle sign. So we're going to change what? The positive to negative. So this is going to be negative 3 minus root 2. Did we change the front sign? No. What sign changed? Just the middle sign. Now, if I ask you, what is the conjugate of negative let's say, how about this? Negative 7 plus 2I root 3. What is the conjugate of negative 7 plus 2I root 3? Remember, conjugate means change which sign? Change middle sign, so we're going to change the middle sign of addition to subtraction. So this is negative 7 minus 2I root 3. And lastly, if I give you this example, 5 plus 7I, okay, what would be the conjugate, or let me do this, 5 minus 7I. Okay, so what would be the conjugate of 5 minus 7I? We change which sign? The middle sign, it would be 5 plus 7I. Notice, did the 5 change? No, we did not change the front sign, we just changed the middle sign. So what does conjugate mean? Right now, conjugate means change middle sign. So how are we going to get rid of this root 3? Well, very specifically, we're going to multiply by the conjugate of the denominator. So we're going to look at this 5 over 2 plus root 3, and we are going to take this, and we are going to multiply by the conjugate of the denominator. Since this is 2 plus root 3, remember, conjugate means change the middle sign. We're going to multiply by 2 minus root 3. Notice, 2 plus root 3 and 2 minus root 3 have opposite middle signs. Now, if we multiply the bottom by 2 minus root 3, we have to multiply what? The top by 2 minus root 3. And now what do? We look at the bottom. We have binomial times binomial. This is a FOIL. So 2 plus root 3 multiplied by 2 minus root 3. We FOIL. Take 2 and multiply by both. 2 times 2 is 4. 2 times the root 3, remember, we glue it together. We multiply number times number, root times root. So since the 2 is not under a root, but the 3 is, we don't actually multiply the 2 and the 3 together. We just glue. For instance, if I say, what is 2 times x? We just write this as 2x. If I say 2 times root 3, we write this as 2 root 3. So 2 times root 3 is 2 root 3. Now be careful. Positive 2 times negative, we have negative 2 root 3. And now we take the root 3 and multiply by both. So root 3 times 2, notice positive times positive is positive. And since the 3 is underneath the root and the 2 is not, we just glue this together. Putting the number first, this is positive 2 root 3. And now we take the root 3 times root 3 and multiply it together. Question, what is root 2 times root 2? Reminding you, when we multiply two roots together, the roots that are identical, the roots cancel out, we just get 2. The root of 3 times the root of 3 is just what? 3. The root of 7 times the root of 7 is just 7. So root of 3 times root of 3 is 3, and positive times negative is negative. Students, you can write the root of 9. Remember that the root of 3 times the root of 3, we can multiply the radicants together and get the root of 9, but this is redundant because then you just have to turn around and simplify the root of 9, which is just 3. So don't write root of 9 because you will oftentimes forget to simplify this. Root 3 times root 3, I agree, is the root of 9, but I want you guys to get in a habit of just saying the roots cancel out and this is just 3. This leads to less errors. So let's go ahead and do this. Root 3 times root 3 is just 3. Now, we're done multiplying. Now what are we doing? We are adding. So we add things that match. Numbers with numbers. 4 minus 3 gives a 1. And what happens with the 2 root 3 and the minus 2 root 3 and the plus 2 root 3? Remember, when we add, something must match, and what matches doesn't change. So the root 3 does not change. We add what's in front. Negative 2 plus 2 is what? 0 root 3. Now what is 0 times anything? 0 times anything is just 0. So 0 root 3 is nothing, and we ignore it. We don't actually even write it. So we say that negative 2 root 3 plus 2 root 3 cancel out. What happens when we multiply identical binomials with opposite signs, or what we say conjugates? What happens when we multiply conjugates together? Notice they have opposite signs. Notice what happened in the center. The center terms had opposite signs and the center canceled. So I say this, when we multiply conjugates, what happens in the center? The center cancels out. So when you multiply conjugates, your center will always cancel out. We're left with, on the denominator, notice, our goal is to what? Rationalize the denominator or get rid of the roots in the denominator. Notice, what is our denominator now? The 2 plus root 3 times the 2 minus root 3 gave an answer of 1. So our denominator is now the number 1. Did the roots go away in the denominator? Yes, there are no longer roots in the denominator. Now on top we have a monomial 5 multiplied by a binomial. What happens when multiplication meets addition? Distributive property applies. So we're going to take the 5 times the 2 and get 10. and take the 5 times the root 3. Now be careful, this is a number, this is a radical. So we're going to glue it together. Positive times negative is negative, so we get negative 5 root 3 over 1. And since this is a denominator of 1, we can ignore it, and our final answer is 10 minus 5 root 3. So if you get a denominator of 1, you can just ignore it and write the numerator, 10 minus 5 root 3, and we're done. Okay, so let's look at another example, and this will clear this up very quickly. So, looking at, for instance, let's do 7 over 5 minus root 11. Okay, 7 over 5 minus root 11. What do we do here? Well, notice we have a root in the denominator, and what else do we have in the denominator? We have addition. Remember, when we have addition separating two terms in the denominator, and we want to get rid of the radical, remember, what is the process of getting rid of the radical in the denominator? We call this rationalizing the denominator to get rid of the root 11. So we want to get rid of the root 11 by rationalizing, but what do we have to do? If there's addition, we multiply by what? We multiply by the conjugate of the denominator. And conjugate means change middle sign, so we're going to multiply by 5 plus root 11. And if we do this on the bottom, we also have to do this on top, so we're going to multiply by 5 plus root 11. And what happens? So on the bottom, we have a binomial times a binomial we're going to FOIL. So 5 minus root 11 multiplied by 5 plus root 11. We end up with 5 times 5 gives 25. 5 times the root 11, we FOIL. Take the first term, multiply by both. 5 times 5 is 25. 5 times root 11, we glue this together as what? 5 root 11. Negative root 11 times 5, we glue this together. The 5 is not under a root, but the 11 is, so we just glue it together as what? Negative times positive is what? Negative 5 root 11. And now we take the root 11 times the root 11. What is root 3 times root 3? It is just 3. What is root 11 times root 11? You guys should become automatic with this. It's just 11. So root 11 times root 11 is 11. And negative times positive is negative. Now, we end up with 5 root 11 and negative 5 root 11. Remember, when we multiply conjugates, the center cancels. So if we look at this, plus 5 root 11 minus 5 root 11 cancel out. So this becomes 0. 25 minus 11 is 14. And our denominator now is just, I'm going to erase this so we have room to write. The denominator becomes just 14. So question, did we successfully get the root of the 11 out of the denominator? Yes. Are we concerned with roots appearing in the numerator? No. We just want to get the roots out of the denominator. So we end up with 14 in the denominator. Now on top we have a monomial. Monomial multiplied by binomial. When multiplication meets addition, we distribute. So 7 times 5 gives what? 35. And 7 times root 11 is what? 7 root 11. We glue it together. And now, unlike the last problem, this problem has to be simplified even further. Notice, what do we have in the denominator? This is a monomial. And if you go back to the division of polynomial videos, we talk about the difference of, okay, so if I have this, x squared plus 5x plus 7 over x plus 3, what do we have in the denominator? We have what? Binomial. When there is a binomial in the denominator, in order to fully simplify, we have to use long division or synthetic division. Remember, our directions are to do what? Our directions are to simplify. So we either use long division or synthetic division if we have a binomial in the denominator. However, if we have a monomial, for instance, x squared plus 5x plus 7 over x, if there's a monomial in the denominator, we simply split the addition in the numerator. We write this as x squared over x plus 5x over x plus 7 over x. Remember that the monomial divides each. We split the addition, and we cancel the x with the x squared, leaving an x. Cancel the x's, leaving a 5. Nothing cancels on the end, so we're left with a 7 over x. Now, what do we have in the denominator? We have a 14. So this is a monomial. We're going to split the addition and write this as 35 over 14 plus 7 root 11 over 14. And now we cancel if possible. Does something divide 14 and 35? Yes, 7 does. So we're going to divide each by 7. 35 divided by 7 is 5. 14 divided by 7 is 2. Now over here we can cancel the 7 with the 14. Divide them by 7. 7 divided by 7 is 1. We don't write the 1. 14 divided by 7 is 2. And our final answer is 5 over 2 plus root 11 over 2. And question, is this considered fully simplified? Yes, we have split the addition because we had a monomial, and before we did that, we got rid of the radical in the denominator. So our final answer is 5 over 2 plus root 11 over 2. So no radicals in the denominator, and we've split the addition and divided and canceled. Now, one more example, and I think that concludes this topic. We're looking at now 3 plus root 2 over 7 minus the square root of 3. Now, in this case, we have roots in both the numerator and the denominator. Are we worried about roots occurring in the numerator? No, we're worried about roots that occur in the denominator. And how do we get rid of roots in the denominator? We multiply by, I should say, when there's addition. When there's addition in the denominator, we multiply by what's called the conjugate, which means what? Change the middle sign. So we're going to multiply by opposite middle sign. In this case, identical binomial with opposite middle sign is 7 plus the root of 3. If we multiply the bottom by 7 plus root 3, we multiply the top by 7 plus root 3. Notice that the binomials on the bottom are identical and have opposite middle signs. We call these conjugates. So we're multiplying by the conjugate of the denominator. And now what do we have to do? We have binomial times binomial, so we FOIL. So 7 minus root 3 multiplied by 7 plus root 3 gives, take the first term, multiply by both. 7 times 7 is 49. 7 times root 3 is positive 7 root 3. Now take the second term, multiply by both. Root 3, negative root 3 times 7 is negative 7 root 3. And negative root 3 times root 3, be careful, root 3 times root 3 cancel out, leaving just 3. Negative times positive is negative. Now, notice we have a positive 7 root 3 and a negative 7 root 3. When we multiply conjugates, the center cancels. 7 root 3 minus 7 root 3 gives 0 root 3, which is just 0. So this cancels out, and we combine our numbers. 49 minus 3 is 46. So we get a denominator of 46. And on top, notice, this is also different. We have a binomial times a binomial. Unlike up here where we had a monomial times a binomial, we also FOIL. Down here we FOIL. So we do what? 3 plus root 2 times 7 plus root 3. I'm just going to FOIL here. 3 times 7 and 3 times the root 3. So 3 times 7 gives 21. 3 times the root 3 gives 3 root 3. Now we're going to take the second term and multiply by both. Root 2 times 7 is 7 root 2. Let me go ahead and erase a little bit. So we're running out of space here. And then the root 2 times the root 3, can we multiply the radicand times the radicand? Yes. Root 2 times root 3 is the root of 6. So we end up with the root of 6. And now, are we fully simplified? No. Remember, if there's a monomial in the denominator, you have to split the addition in the numerator. So we're going to write this as 21 over 46 plus 3 root 3 over 46 plus 7 root 2 over 46 plus the root of 6 over 46. And notice, does anything cancel with your 21 and 46? No, it does not. 21 has factors of 3 and 7, and 46 is 2 times 23. Nothing cancels from the top to the bottom here, so we just leave it as 21 over 46. Does something divide 3 and 46? No, it does not. Does something divide 7 and 46? No. So we are done. Circle this as your final answer. And I want this right here to be a very good example of, does the word simplify mean to make simple? No. I think this is a good example because what did we start with? We started with a problem 3 plus root 2 over 7 minus root 3. And if you ask my opinion, I think you would probably agree. If we look at the original problem, the directions in the book said to simplify. The original problem looked pretty simple. But after we simplified and followed all of our rules, look at the final answer. Does the final answer look simple, or does it look much more complicated than what we started with? It looks far more complicated. So does the word simplify mean to make simple? No, it does not. Most of the time when you simplify something, it gets smaller, or it looks more simple when you're done. But in this case, we notice, when we follow the rules of simplification, our answer looks far more complicated than what we started with. So here's a good example of, does the word simplify mean to make simple? No. Simplify means to literally add, subtract, multiply, and divide until you cannot do this anymore. So you're putting little towers together very quickly. You're putting things together in this class right now. It's like taking Legos and putting them together and building a little tower. Soon I'm going to ask you guys to go backwards and take everything back apart again. Right now you're taking this and you are simplifying. Soon I will ask you guys to go backwards and you will take what simplified and work backwards to the original problem, and the backwards process is called factoring. So to unsimplify, you can think of factoring, what's coming. Factoring is the concept of unsimplifying. Now if I say it like this, if simplify meant to make simple, then factoring would mean to make complicated or to complicate. Not really, because simplify does not mean to make simple, and factoring does not mean to complicate. These are just words that we use that mean simplify means to add, subtract, multiply, and divide, or put things together. Factor means to do the complete opposite and break things back apart again. Or I say this, factoring means to create products. We'll talk about this more. Good luck with your homework, guys. Have a good night.